So in this particular session, we are still covering about indices. So we are looking at example number 4. Okay, so what we've been given is that basically we've been given this equation. So it's 1 upon 1 plus x to the power l minus m, x to the power l minus n, right? So what we can basically write is ax minus y. I can write it in this form. Right? So similarly, we will write it in all of this in this form. After that, let's take some LCM and then let's try and find out how we can solve this particular question. Okay. So 1 upon 1 plus x to the power l, right? And then x to the power m plus x l and then x to the power n, right? Similarly, in this case as well, 1 plus x to the power m, x to the power n plus x to the power n, x to the power l, right? So similarly, in this case as well, 1 plus x to the power m, x to the power n plus x to the power n, x to the power l, right? So let's take the LCM after this. So since this is xm and then xn, so they are two different terms, right? So we need to multiply it, right? So 1 upon xm dot xn plus, why have I done that? Because it is 1, it does not have anything on the base, right? So both of them will go there, right? So similarly, in this case, xl is already there, so xn is not there, so that will be multiplied. Okay, so xn plus x to the power l and then x to the power n. In the base, you will have x to the power m and then x to the power n as well. Okay, so similarly, in this case, x to the power n and then x to the power l, right? Plus x to the power n, x to the power n, right? So upon what will happen? X to the power n, x to the power n, right? So similarly, in this case as well, same thing, x to the power n, x to the power l, right? So x n dot xl plus x to the power n dot x to the power n. So x to the power n, x to the power l, right? So let's have a look. Okay, so how do we add it? Okay, so this will go up. After that, we can write it in that form, and then that, and then similarly for that as well. So we will get 1. Okay, so your answer will be 1, I think. So can I write it in this form? I took this up, and then so since we know that ax ay can be written in the form of ax plus 1, right? That's all I'm doing over here as well. So similarly, down below as well, x to the power m plus n, right? So plus x n plus l. Why have you not done n plus n? Because if I don't do this based on this, so see, when you take this up, you'll get n plus l, right? So if you have n plus n over here, it's just the same thing, but still, like, just to make it so that you can have just to not to make you confused, it will be better idea, okay, to do it this way. So x n plus n. Okay. Again over here, x to the power n plus l. X to the power, can I bring this to the front? N plus n plus x to the power n plus l plus x to the power l plus n. Okay. So this is just shifting it here and there. Okay. So same thing over here as well. So x to the power n plus l. In the base, you will have x to the power mn plus x to the power n plus l plus your x to the power n plus n. So now what I can do is basically, let's take the LCM first of all, okay? So x m plus n plus since the denominator is same, we can just add it together, right? Down below as well, it will be same. One, right? So this is how we can basically solve this kind of problems, okay? So as you can see, so all we need to do is that just try to solve, use your laws of indices. After that, your simple LCM, and then after that again your product law, and then just basic simplifications only. Okay, so this is how we solve this kind of problems. If you have any doubts regarding this particular question or anything regarding indices, please do comment down below. I'll definitely be happy to answer it for you. Until next time, bye bye.